Hi my dear students, welcome to our channel Learn Physics with Guna sir. If you are watching our channel first time, please subscribe. For more updates, click the bell icon. Thank you. Welcome my dear friends. Today our experiment is Newton's rings. It is the example for interference of light. Theme of the experiment: to determine the radius of curvature of a given lens by forming Newton's rings. Required apparatus: sodium vapor lamp. This is also called as monochromatic source of light. Traveling microscope, plano convex lens and plain glass plate. Procedure: now how to do the experiment is: place the convex lens with its convex surface in contact with the surface of the glass plate. This is a plain glass plate. We are keeping that on graph paper to avoid the transmission of the light. Above that, we need to place the convex lens and we need to arrange the apparatus as shown in the diagram. That means we need to arrange another glass plate with 45 degrees angle to the plano convex lens. The light rays fall on the plain glass plate with inclined with 45 degrees angle. They are once again fall on the plano convex lens surface. Now view the rings through the microscope. Edges the microscope's crosswires coincide with the central dark spot. In between the lower surface of the plano convex lens and upper surface of the plain glass plate, the varying thickness of air wedges formed. There, these rings are formed. At the center, we can observe the dark spot. From that, we can observe a concentric circular bright and dark rings. That bright rings are due to the constructive interference and the dark rings are due to the destructive interference. By using the tangential screw, we have to move one side of the rings. We have to start the counting of the rings, bright rings, like 1, 2, 3, 4 up to the 10. We need to focus the crosswire for the 10th ring to determine the radius of the bright ring. Here we need to take two readings. One is main scale reading and another one is vernier coincidence. This is vernier scale. The first one is, this is main scale. So here main scale reading is 4.7 and vernier coincidence is 57. Okay. Now move the microscope and make the vertical crosswire coincide with the 8th, 6th, 4th, 2nd ring and note down the readings of the main scale reading and vernier coincidence. So same like that we have to repeat the experiments towards the left side of the rings to determine the radius of the bright and also the dark rings. Tabulate all the readings and calculate the diameter of each ring. From that diameter we will calculate the radius of curvature of given plano convex lens and our wavelength of the source of the given source of light by using the Newton's rings experiment formula. Lambda equals to dm square minus dn square by 4r into m minus n, or r equals to dm square minus dn square by 4 lambda into m minus n. Plot the graph between the number of the ring and diameter of the rings. On x-axis we need to take the order of the rings, that means number of the rings, and on y-axis we have to take the diameter of the rings. We will get the graph like that. Now once again we have to calculate the radius of curvature from the graph also by taking the m value and n value and corresponding dm square and dn square values. So finally we got the radius of the curvature of the given lens, that is 100 centimeters. Thank you for learning.